So in this video, we're going to talk about how to solve exponential equations with two powers. So to solve exponential equations with two powers, we're going to take the log of both sides whenever there are variables in the exponent. Then we're going to apply the power properties, simplify if needed, distribute, group the terms of the variables on one side, factor out the variable, solve for the variable, and then approximate the solution. So let's look at a problem like this. Notice that we have exponents on both sides that have a variable in them. So we're going to go ahead and take the log of both sides. So we have the log of 5 to the 2x equals the log of 2 to the 3 plus 5x. Okay, so now what we're going to do is we're going to use that power property and we're going to bring that exponent down in front. So we have 2x log 5 equals 3 plus 5x log 2. So what I'm going to do now on the right side is I'm going to distribute that log of 2, and you're going to see why I did this in the next step when we move all the terms of the variable to one side. So we have 2x log 5 equals 3 log 2 plus 5x log 2. So notice I have a term with an x here and a term with an x here. So I'm going to subtract 5x log 2 from both sides in order to get all the terms with a variable on one side of the equation. So when we do that, we get 2x log 5 minus 5x log 2 equals 3 log 2. Okay, so notice I have two terms that have an x in them, right? So what I'm going to do is I'm going to factor that x out. So we have x times 2 log 5 minus 5 log 2 equals 3 log 2. So now I'm going to get that x by itself by dividing both sides by 2 log 5 minus 5 log 2. So what happens on the left side here is that these terms will cancel. So I will have finally x by itself. So I have x equals 3 log 2 divided by 2 log 5 minus 5 log 2. So if I want an approximate solution, I'm going to go ahead and enter this all in my calculator. So I'm going to do 3 log 2 and then hit enter, and then do divided by parentheses 2 log 5 minus 5 log 2. And so you have to put that denominator in parentheses so that it reminds to divide by the whole thing. So we get x is approximately equal to negative 8.4236. Okay, so both of these answers are correct. So now let's go ahead and solve this equation. So in this equation, we have 5 to the 2x minus 1 equals 3 to the x. So once again, I'm going to take the log of both sides. So we have the log of 5 to the 2x minus 1 equals the log of 3 to the x. So we're going to go ahead and bring those exponents down in front. So we have 2x minus 1 log of 5 equals x log of 3. So once again, I'm going to distribute over here. So I have 2x log of 5 minus 1 log of 5 equals x log of 3. So I'm going to move all my terms that have an x in them to the same side of the equation. So what I'm going to do is I'm actually going to add this log 5 to both sides. So I can move that over to the right. And when I do that, I get 2x log 5 equals x log 3 plus log 5. And then I'm going to move this x term over here. So I'm going to subtract x log 3 from both sides. And so when I do that, I get 2x log 5 minus x log 3. And then this cancels, and that equals a log of 5. So now what I'm going to do is I'm going to factor this x out of both of these terms. Okay, so when I factor that x out, I have x times 2 log 5 minus log 3 equals the log of 5. So now to get x by itself, I'm going to divide both sides by that 2 log 5 minus log 3. And then that is going to leave me with x equals the log of 5 divided by 2 log 5 minus log of 3. Okay, so that is the exact answer. If I want to get an approximate answer, I'm going to use my calculator. So I'm going to do log 5 and then hit enter. And then do divided by parentheses 2 log 5 minus log 3. And when I hit enter again, it gives me that x is approximately equal to 0.7591. Remember that when we're working with logs, the convention is to round to about 4 decimal places. So now let's try this equation. We have 4 to the x plus 2 equals 9 to the 2x. So once again, I'm going to take the log of both sides. So the log of 4 to the x plus 2 equals a log of 9 to the 2x. So I'm going to bring that exponent down in front. So I have x plus 2 log 4 equals 2x log 9. So I'm going to distribute this log 4. So I get x log 4 equals plus 2 log 4 equals 2x log 9. Okay, so now I want to get all my terms with an x on the same side, so I'm going to go ahead and subtract x log 4 from both sides. So when I do that, on the left side, all I'm left with is 2 log 4. So I have 2 log 4 equals 2x log 9 minus x log 4. And now that I have two terms with an x in them, I'm going to factor that x out. So I have 2 log 4 equals x times 2 log 9 minus log 4. So I'm going to divide both sides by that so that I can get the x by itself. So I'm going to divide both sides by 2 log 9 minus log 4. And so when I do that, on the right side, notice that these two terms cancel. So I have 2 log 4 over 2 log 9 minus log 4 equals x. Okay, so if I want to get an approximate answer, I'm going to type this in my calculator. So I'm going to do 2 log 4, hit enter, and then do divided by parentheses 2 log 9 minus log 4. And so when I do that, I get x is approximately equal to 0.9217. So now let's try solving this problem. Notice that this problem has a base of e in it. So whenever we have a base of e involved, we want to actually take the natural log, right? We don't want to use the common log. So I'm going to take the natural log of both sides of this equation. And so that gives me ln of e to the x. And once again, I'm going to bring my exponent down in front. So I have negative 3x plus 2 ln 8 equals x ln e. And then now I'm going to distribute over here. So I have negative 3x ln 8 plus 2 ln 8 equals x ln e. And notice that the natural log of e is what I have there. Remember, if you have the same base and you're taking the natural log of that, that's just going to be 1, okay? So I have negative 3x natural log of 8 plus 2 natural log of 8 just equals x. So now I'm going to combine all my terms with an x on one side. So I'm going to add 3x natural log of 8 to both sides. And when I do that, I'm left with 2 natural log of 8 equals x plus 3x natural log of 8. Okay, so now I need to factor out this x. So I have 2 natural log of 8 equals x times, when I factor out an x from the first term, that just leaves me with 1. Because remember, factoring it out means I'm just going to divide both these terms by x. So I have 1 plus 3 ln 8. And now what I can do to get x by itself is divide both sides by 1 plus 3 ln 8. So when I do that, on the right side, this is going to cancel, leaving me with just x. So I have 2 ln 8 over 1 plus 3 ln 8 equals x. And so that's your exact answer, right? If I want to find an approximate answer, I'm going to go to my calculator and do 2 ln 8, hit enter, and then do divided by parentheses 1 plus 3 ln 8. And then when I hit enter, it gives me x is approximately 0.574 and 6. Okay, so now let's solve this equation. Once again, we have a base of e, so I'm going to take the natural log of both sides. So we have the ln of 5 to the 4x minus 3 equals the natural log of e to the 3x plus 6. Okay, so I'm going to go ahead and bring that power down in front. So I have 4x minus 3 equals the natural, not equals, 4x minus 3 times the natural log of 5 equals 3x plus 6 natural log of e. And then what we're going to do is we're going to simplify what we have. We're actually on the left side, we're going to distribute. So we have 4x natural log of 5 minus 3 natural log of 5 equals, and then here on the right, this natural log of e is just 1. So that's just going to leave me with 3x plus 6. So now what I need to do is move all my terms with an x to one side. So I'm going to move the x terms to the left and then the other terms to the right. So I'm going to subtract 3x from both sides. And so that gives me 4x ln 5 minus 3x minus 3 ln 5 equals, here this cancels, so I have 6. Now I'm going to move this 3 ln 5 to the right because that doesn't have an x in it. And so that gives me 4x ln 5 minus 3x, this cancels, equals 6 plus 3 ln 5. Okay, so now I have two terms that have an x in them, so I'm going to go ahead and factor out that x. So that gives me x times 4 ln 5 minus 3 equals 6 plus 3 ln 5. So now I just need to divide both sides by 4 ln 5 minus 3, and that is going to allow me to solve for x. So when we do that, we get x equals 6 plus 3 ln 5 divided by 4 ln 5 minus 3. So that is our exact answer. If we want to get an approximate answer, we have x is approximately equal to, I'm going to go ahead and do 6 plus 3 ln 5, hit enter, do divided by parentheses, 4 ln 5, and then minus 3. Remember to close the parentheses on the natural log before you type the minus 3. And that tells me x is approximately 3.1498. So now you can pause the video and try this example on your own. So when we do this problem, our strategy is going to be the same. Since we don't have an e, we're just going to take the regular log. So we're going to do the log of 3 to the 2x minus 1 equals a log of 5 to the x. Okay, so we're going to bring that exponent down in front. So we have 2x minus 1 log 3 equals x log 5. So now what we need to do is we need to distribute that log of 3. So I'm going to distribute that log of 3. And so that gives me 2x log 3 minus log 3 equals x log 5. So now I need to move all my terms with a variable in them to one side of my equation. And so when we do that, we're going to subtract 2x log 3 from both sides. And so that gives us negative log 3 equals x log 5 minus 2x log 3. So notice that both these terms have an x. And so we're going to factor that out. So we have negative log 3 equals x times log 5 minus 2 log 3. So we're going to divide both sides by that log of 5 minus 2 log 3 in order to solve for x. So we have negative log 3 divided by the log of 5 minus 2 log 3. And so that is the exact value of x. And so now we're going to approximate it by going ahead and entering this in our calculator. So we have negative log 3, and then you hit enter, and then do divided by parentheses. Remember, this denominator has to be in parentheses. Log of 5, close parentheses, minus 2 log 3, and then close both parentheses, and that gives us x is approximately 1.8691. So remember, to solve exponential equations with a power on both sides, you're going to take the logarithm of both sides whenever there are variables in the exponent. Then you're going to apply the power property to simplify if needed and distribute. Then you're going to group terms with a variable on one side of the equation, factor out the variable, and then solve. Then you're going to approximate the solution.